Krishna. So this is day 2 of October challenge. So we'll try to understand this problem statement. So we will be given n pieces arranged in a line. So it's nothing but like we will be given colors as a string. Okay. So basically it's a kind of game. So there are two players, Alice and Bob. So they are playing and where they take alternating turns. Okay. Initially we start with Alice. So Alice is allowed to remove a piece colored A. So these colors are either A or B. Okay. So he can remove a colored A if both its neighbors are colors also A. Okay. And she is not allowed to remove the colors of B, colored B, pieces which are colored B. So same applies to the Bob. So is allowed to remove the piece colored B if both its neighbors are colored B. He is not allowed to remove the pieces that are colored A. Now Alice and Bob cannot remove pieces from edge. Okay, and if a player cannot make a move on their turn, that player loses, and you need to make another player as a win. So you need to return true if Alice wins, or else you need to return false. That indicates Bob wins. So let's try to understand this problem statement. Basically, we will be given a string where they colored A, B. Okay, A, B, A, B, B. Let's assume this is one of the input. So initially, Alice takes a move, right? So she's now can remove this one because its neighbors are is A. So B. After removing this, it looks like this. So now it's Bob turn. So Bob cannot make any move, right? Because there is no B where the both side neighbors are colored as a B. So absolutely here Alice is the winner. Okay, then you need to return true. Okay. Example, we take another one. A, B, 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 B. Okay, 7 Bs. And then A. So Alice takes the first move. So she can remove this one. Okay, after removing this, there is only two A's at last. Then Bob's comes into the picture. So he can take any, what I can say, B into consideration. Let's assume like he removed this one. Then it looks like A. Okay, after their both turns. Now Alice. So now she cannot take any move because like there is no A where both neighbors are colored as again A. So now Bob is the winner. That means you need to return the false. Okay. I hope you understood the problem statement. So now let's try to see how we can solve this problem. So to solve this problem, all you need to do is you need to count the occurrences of these combinations, triple A and triple B. That's it. And then at the end you need to return. Let's assume this we say Alice count, this we say Bob count. Okay, then you need to return at the end Alice count greater than Bob count. That's it. Okay, you might not understood. Let me make it simplified. So basically what we are going to do here is, if you think logically, B. For this example, Alice count is going to be 1 because there is one occurrence of triple one. Okay, but there is no Bob count, right? Because there is no combination of these triple B's occur. So ultimately, Alice is the winner because Alice can take first move, but Bob is unable to take a move. That's it. So now let's take another example. B, and triple A. This is another example. So where Alice count is 1, right? Because there is only one occurrence of triple A. But Bob count is more, right? So this can be 1, this can be 1, this can be 1, this can be 1, and this can be 1. Total 5. So if you observe carefully, so once Alice take one move, Bob can take one move, then Bob will come 4. Okay, and Alice 0. So now there is no move Alice can take, but there are 4 moves Bobs can take. That means now Bob is the winner and Alice is the loser, right? So to put it in simple word, just count the number of occurrences and return the this condition. I mean, Alice count greater than Bob count. Okay, why only this condition? Let me explain that also quickly. So if if Alice count, okay, equal to Bob count, Okay, in this case also Alice is the loser, Bob is the winner. The reason is like, so let's assume 2 they are. So Alice took one, Bob took one, Alice took one, Bob took one, then they both 0 0. Now there is no move for Alice because initially we starting with Alice only, right? So there is no move for Alice. Then absolutely Bob is the winner in this case. Okay, in this equal. So let's assume one more case also. What if Alice is less than Bob? So that's what we discussed, like 1 and 5. So after taking 1, then it's become 5. Then absolutely winner is. So what if 3 and 2? That means like Alice count is 3, Bob count is 2. So first Alice takes, Bob takes, Alice takes, Bob takes, and then Alice one more time she can take because she's 3. But Bob cannot take at this point because he done with taking 2 moves. So now ultimately what I can say, Alice is the winner. So Alice can only be the winner if her count is greater than the Bob count. Otherwise, she won't become winner. Okay. In both the cases where Alice count equal to Bob count or else Alice count less than Bob count, in both the cases, Bob is going to be the winner. But only in case of Alice count greater than Bob count, in that case only Alice is going to be the winner. And I hope you understood the logic behind this problem. So we quickly see timing space complex. So the time complexity is going to be big often because you are going to iterate through these characters to count the occurrences of these combinations. Okay. And space complexity is going to be big often because we are not going to store this input anywhere. Rather, we just take a two constant just to have a counter. Okay. So Alice count is incremented every time when this kind of combination found. Bob count incremented every time when this combination found. Alice count decremented when he takes moves. That means she removes one character from here. It will be decremented, and same applies to the Bob. So at the end we return this one. That's it. Now quickly we'll see in the code and maybe you can understand. So to save some time, so I am taking my previously submitted code. That means my last submitted code. So I took this Alice count and Bob count. So I am starting from index 1 till the length minus 1 I plus plus because I'm starting from 1 because I need to know the previous count that is at index 0, and I am going till length minus 1 because I need to know the character index character also. Okay. Then I'm taking this current character into the ch, okay, whether it may be a or b. Okay, then I check if the current a is equal to previous a, or else if current a is equal to next a, or else it can be b also. Your current character can be b also. Okay, so the goal here is we check the left and right. If both are equal, then we'll come here. In that case, if current count is A, that means previous also A, next also A. That means Alice count will be incremented. Otherwise, Bob count will be incremented. Right? If there is no that condition like triple A, triple B, then this if it itself is not going to be true. Right? So then we'll go to next character. So at the end, we are returning Alice greater than Bob. Only this is the possible condition where Alice can be the winner. Okay, now let's quickly submit it. Okay, we'll submit now. Cool, it got submitted successfully. So that's all for this video. Please do subscribe and don't forget to tap the bell icon so that you won't miss any updates from my end.